Modern life would hardly be possible without products derived from crude oil. These include fuels and oils for most forms of transport, lubricating oils and tar and bitumen for road surfacing. Crude oil is also the starting material for a huge variety of organic, carbon-based chemicals and products such as plastics and synthetic fibres. Most UK oil refineries are on the coast. The Shell refinery at Stanlow in Cheshire is close to the Mersey and Dee estuaries. There are good road and rail links to other parts of the country. At Shell's Stanlow site, two crude distillers together process 34,000 tonnes of crude oil per day. This is brought from the North Sea, the Middle East, North Africa and Russia. There is also a catalytic cracker and a platformer for converting straight chain molecules to branched chain. On site is a range of storage tanks for the different products. Rail and road links are on site and sea transport a short pipeline away. Crude oil is brought in by ship to Tranmere Oil Terminal. It comes mostly from the North Sea and is then transferred by pipeline to storage tanks at Stanlow. Many of the products of the refinery are used by the chemical industry in the surrounding area. This is crude oil. It's a mixture of different hydrocarbons. The first step in refining is to separate the oils into fractions of different boiling ranges by fractional distillation. The crude oil is first heated by gas or oil-fired burners. This vaporizes most of the oil. The vapor is fed into the bottom of the fractionating tower, a column containing over 40 perforated trays. The bottom of the tower is kept at 360 degrees Celsius and the top at about 100 degrees Celsius. The vapours rise up the tower and condense to liquid when they arrive at a tray that is sufficiently cool. The perforations in the trays allow vapours to rise up the tower and liquids to drip down. Liquids, called fractions, are piped off at different levels in the tower. The higher up the tower, the lower the boiling point, and the shorter the hydrocarbon chains. Gases from the top of the tower are used as fuel gases, both for sale and in the refinery. The thick liquid residue from the base of the column may be distilled again under reduced pressure to give further separation. There is more demand for the shorter chain fractions from the initial or primary distillation than for the longer ones. Longer chain fractions are therefore cracked, a process of breaking the molecules to give shorter chain fractions. 10,000 tonnes of petroleum fractions are cracked each day at Stanlow in this plant. In catalytic or CAT cracking, the long chain fraction is mixed with a powdered catalyst of silicon dioxide and aluminium oxide, and the mixture enters the reactor at about 500 degrees Celsius for 5 seconds. Here the cracking takes place. The catalyst becomes coated with carbon and is recycled. The catalyst passes to a regenerator where the carbon is burnt off in air. The hot gas from the regenerator is used to turn the turbine of an electrical generator so that its energy is not wasted. This gas contains carbon monoxide from the burning carbon. This can be used as a fuel on site. The mixture of shorter chain products goes to be separated by distillation. The products of cracking include alkenes. These are hydrocarbons with reactive double bonds. They are vital starting materials for chemical processes such as polymerization. Valuable short-chain alkanes for petrol are also produced. After fractional distillation and cracking, fractions may undergo further treatment, including desulfurization to remove sulfur, which would produce sulfur dioxide when the fuels are burnt. Platforming, in which straight chains are converted to branched chains by heating over a platinum catalyst. The branched chains produced better quality petrol. Fractions are also blended, mixed to give products of the required properties for use as fuels and lubricants. From Stanlow, 30% of the production goes by pipeline to the Midlands, London and Manchester. The rest is transported off-site by road, rail and sea.